these are often misunderstandings, and you get this in every unit in chemistry, where you take things at little bits and little bits and little bits, you know how to do them, but then you can't kind of see the forest for the trees at the end. And that's what these highlight. Okay? There is a difference in question 1 and 2. So if you've answered question 1 and 2 the same way, you haven't understood the difference between the compounding 1 and the compounding 2. So let's just talk about question 1 for now. Question 1, I'm asking the pH. I have how many molarity or moles per liter of HCl. So in Chem 20 we learned this, right? And if you had a good Chem 20 teacher, you learned that you're supposed to add water there because this is H3O plus. And in Chem 30 we start learning about how that's because this is accepting a proton that way. Everybody okay with that? But at any rate, I have 100% arrow here. That means if I have a 0.1 mole per liter solution, as the question says, how many mole per liters is my H3O plus? 0.1 moles per liter. Right? And pH equals? And so therefore, negative log of 0.1, and so therefore 1. And I'm done. That is Chem 20. All over the place. Everybody okay with that? So the pH is 1, and I got there by going directly to pH equals negative log concentration of H3O plus. What's the difference between HCl and CH3COOH? Good. This is a weak acid. Can you see that this is a carboxylic acid, everybody? Can you see COOH, COOH, that this is not a hydroxide? It is not a base, that this is a carboxylic acid, acid. It's called ethanoic acid, or acetic acid, or vinegar. Everybody got that? Okay, the other one that might throw you off with the OH is this one, which is an alcohol, methanol, from the organic unit. Not a base. Do you see that it's not a base? Because it's not a plus and a minus, like Na plus OH minus. That's not CH3 plus. No. They are molecularly bonded. It's a molecular compound and it's an alcohol, not a base. Okay, so back to this question. This is a weak acid. If it's a weak acid, do I have 100%? No, in fact, it exists in an equilibrium. That's the Chem 30 part. So this and water, so I'm doing the same thing that I did with the HCl. I'm doing the same proton as the HCl, only this time I'm writing these arrows. And I get H3O plus and CH3COO minus. And those arrows mean that even if I started with 0.1 moles per liter of this, I will not have 0.1 moles per liter in equilibrium of my H3O plus. In fact, it sounds a little bit like I'm doing an ice table now, right? But I don't want to do an ice table. Davin doesn't want to do an ice table. There's a nice little shortcut that we can do with KAs. Remember these shortcuts? So that equilibrium, how much actually goes, is a constant called Ka. And that constant, Ka value, equals your H3O plus times your CH3COO minus divided by your CH3COOH. Have you memorized the general formula yet for the acid and the base? If you haven't memorized the formula for the acid and base, Ka equals, you probably know this part already. Do you know that part? And then you know that somewhere in this formula you need to put an HA and an A minus. Right? So that's the two that students that know a bit about this know this and they know that. They're just not quite sure where to put these. Which one goes on the top and bottom. It comes from a balanced chemical equation. So neutral, right? Balanced. So my top and my bottom have to be balanced as well. So if I already know that my H3O plus goes up there, in order to make sure it's balanced, my neutral has to go on the bottom and the negative has to go on the top in order to be neutral and neutral. Do you see that? While I'm talking about this, I'll do KB. KB equals OH minus and something about this. Right? And so how do I do that? It has to be balanced. So if I already have a negative on the top and I have to deal with another negative and a neutral, I better put the other negative on the bottom and the neutral on the top. So now I have negative, negative balanced. So that's how you memorize kind of what order to put them in if you've got it half memorized, but you just need to polish it off. Everybody understand that? Okay, so here's my Ka expression. And what did we say we could do with the Ka expression? Well, these would always be equal because it's a 1-to-1 ratio. So that's x squared. In Chem 30, we can always assume that the initial at the bottom is the initial. So this is 0.1 moles per liter. The Ka I can get off of the data booklet. So it is, I think, 1 times 10 to the power negative 8. Or negative 5.
Negative 5.
Negative 5? And now I go 1 times 10 to the power negative 5, or e negative 5, times 0.1, and the square root of that answer is 1 times 10 to the power negative 3 is my x. And what is my x? H3O plus. Remember this? Yes? And now I've got an H3O plus, and now I can plug it in to pH equals negative log H3O plus. So if I take the log of my answer that I just had, I get that the pH is 3. It's a weak acid. Does it make sense that the pH is 3 and not 1 as you said before? And the strong acid is a pH of 1. That makes sense too. Okay? So, if I'm doing a strong acid, I can just go directly into this formula. If I'm doing a weak acid, what I need to do is I need to do first Ka equals x squared over initial concentration, and then my x equals my H3O plus, and then plug that into pH equals negative log of my x. So I've got to do that extra step if it's a weak acid. Everybody get that? Why do you need to do the extra step? Because it's the equilibrium, not stoichiometry 100% goes across. Okay? And both of those questions are valid on the diploma, final, unit exam, because they show that you understand that there's a different pathway, whether it's a strong acid or a weak acid. It shows that you understand 100% ionization, equilibrium, etc. Okay? Questions on those two and the comparison? You knew how to do this, and you knew how to do this, but you didn't quite put them together. And now you can. Okay. Question 3. So this is another concept that kind of gets left in the works a little bit. The Kb expression for ammonia. So, Kb equals, what is the general formula?
OH minus.
OH minus.
HA.
Right? Okay. I'm asking for ammonia. Does ammonia go, is ammonia the H plus or is or A minus amine, or is the ammonia the HA? It's the A minus. How do you know that? Because it's the base. Okay. So here, oh, did it wrong. Okay, so here it's the gaining a proton, here it's the losing a proton. This is a conjugate acid-base pair. This is the conjugate base, this is the acid. Look up in your data booklet what that looks like in the base column. And look at its conjugate acid that I put up there. If you remember, HA is in the acid column and the A minus is in the base column, and I look up NH3 for the A minus, then this is NH4 plus wherever I put my HA in the formula. See that? Okay, so those two go together. How do you calculate the value for Kb? Good? So Kw is 1 times 10 to the power negative
14.
and the Ka, according to the data booklet, is
5.6 times 10 to the
negative,
10.
and therefore your answer ended up being,
1.79 times 10 to the negative.
we only have two significant digits, so 1.8.
No, that was the 2.
Pardon? Okay. Not two after the decimal place, two in total. Everybody okay with that? Yes? Okay, let's do a little harder one then. What about the Kb expression for HOOCOO minus? Right, the expression, and what is the value? So Havy's gone straight to the data booklet, which is good. You are going to find this ion in both columns, the acid column and the base column. Oh, crud. Which column am I supposed to find it in? The base. What column did you find your NH3 in? The base. You found your NH3 in the base, we're going to find this one in the base.
There's supposed to be 2 C's.
Yeah.
Oh, 2 C's. Thank you. Thank you. 2 C's. Hydrogen oxalate ion or whatever, yeah? Okay, so once I found it in the base column, what is the acid? What does it look like after it's donated or after it's accepted a proton? HOOCOO or double C? H. See how those are paired? See how I could get it wrong if I looked at the wrong column? Okay, and trust me, if this is multiple choice, both answers will be there. And therefore your Kb would be different too, because the Ka of that column is different. Okay, so if you're finding Kb, you look it up in the base column. Because you wanted to have accepted a proton to get to your HA. Okay? Everybody okay with Kb now? Melissa?
Yeah.
Okay. All right, so question 4. Now, I said, this is taking you more than 30 seconds, you're doing it wrong, right? And because you can calculate the pHs for each of these, like we did for question 1 and 2. Figure out, is it a strong acid or weak acid? If it's a weak acid, do the Ka, then pH equals negative log, right? Strong acid, oh good. Just plug it into the formula, okay? But that'll take you a long time. The lowest pH must be the strongest acid. Do we happen to have a list of strengths of acidity? Oh, in your data booklet, these ones in the top right-hand corner are the strongest acids. Down, and they go weaker as you go down. Here are your strong bases, and they go weaker as you go up. If I asked you which is your strongest reducing agent, would you be doing math, or would you just go to the data booklet and find the bottom left-hand or bottom right-hand corner ones for the reducing agents, right? Same question, and they love this question. So you find them. You find HF. You find H2CO3. You find which one is your strongest base or acid. I mean, which is your strongest acid of these three that they'll have the lowest pH? I believe H2SO4.
No, HBr is above.
Oh, HBr is above. Okay. Thank you. So HBr is your strongest, therefore it'll have the lowest pH. Done. Okay, and they love asking it as lowest pH, highest pH, most acidic, most basic, strongest acid, weakest base. Okay, in either case, in any of those questions, same thing. Jump to the data booklet and have a look. Okay, simple. There are 2 of these in that practice test that you did over the break. Question 5, the conjugate acid of that means that this is a base, and I'm looking for what does it become on the other side of the arrow when it becomes a conjugate acid after it has, by definition of base, accepted a proton. What is this thing going to look like after it's accepted a proton? H2CO3. Yeah, you can look it up in your data booklet too if you like. You could look it up in the base column and find out what its conjugate acid is, as long as you remember the base column. But the first thing you have to recognize is if I'm asking what is the conjugate acid, I'm looking for that as a base. Okay, so here's another question then. What's the conjugate acid of X minus? HX. This must be a base. It's going to accept a proton. Here it is, accepted the proton. Okay? All right, so hopefully that's cleared up some misunderstanding.